Hi there, and thanks for watching this video. Our goal for this learning target is to be able to solve some trigonometric equations, things that look like this. Cosine of x equals negative 1/2. Now, it's worth pointing out in the instructions here, it says solve this on the interval from 0 to 2 pi. So in other words, I'm only looking for values of x that are between those two values. So I want x's that are less than or equal to 0. Notice that the right endpoint here is an open interval dot, so we need less than 2 pi, but not equal to 2 pi. So it's worth noting that one way to interpret this problem might be find all the places on the unit circle where this statement is true. So if I look at this equation here that says cosine of x equals negative 1/2, essentially what I'm doing is I'm going to look at my unit circle. And I'm going to say, okay, on my unit circle, which is right here, where would the cosine, remember that the cosine of a value on the unit circle is the x-coordinate, where would the cosine be negative 1/2? So I'm looking for all of those places. So I think cosine is negative 1/2 right here at 2 pi over 3, because the x-coordinate is negative 1/2. And I think there's one more, I think right here at at 4 pi over 3. So those would be the two values we're looking for. So I'll write it as a solution set. I'll say that x could be either 2 pi over 3 or 4 pi over 3. And those are all the values that solve that equation. Now the second equation is asking for all the values of x on the unit circle where the tangent of x would be square root of 3. And that can be a little trickier in the sense that remember that on the unit circle the tangent of an angle is y over x. So I do have to do a little bit of figuring out which values we're talking about. I need to know where I get square root of 3. I think one of them is here. Right here at pi over 3, because if I put square root of 3 over 2 over 1/2, I would get square root of 3. And I think another one of them is actually down here at the same place that we had for our first equation, 4 pi over 3. If I let negative square root of 3 over 2 divided by negative 1/2, the negatives would cancel, the 2's would cancel, and I would get square root of 3. So those are my two values that I'm looking for. I'm looking for pi over 3. And 4 pi over 3. And this is probably the most basic type of equation you might be asked to solve. Okay, what you have now are a couple of slightly more difficult equations in the sense that maybe you have to do something to isolate the trig function first to get it set up like the ones previously where we ask for a trig function equals a value. So for example, if I look at this first equation, square root of 2 times sine of x plus 1 equals 0, it sure would help to be able to get this sine of x by itself first. In other words, we're solving for sine of x before we try and figure out what x values we need. So I can do that by subtracting 1 from both sides. I would have square root of 2 sine of x equal to negative 1. And if I divided both sides of this equation by square root of 2, I would get sine of x equals negative 1 divided by square root of 2. And of course, if I were to rationalize that, and you guys are pretty good at doing this without writing that step out, I would get sine of x is negative square root of 2 over 2. So this is a good example of how I had to solve this for the trig function first. But now I can use that same idea. On my unit circle, where would I get a value of negative square root of 2 over 2 for the sine? And I'm not going to put the unit circle back on the screen here, but you have it in front of you. You can see that those angles are 5 pi over 4 and 7 pi over 4. So those are the two values where this equation is true on the unit circle. Now if I look at an equation like the one here on the right, that says 4 cosine squared of x minus 3 equals 0, I can solve this in a very similar way. All I'm going to do is I'm going to solve first for the cosine squared of x. So I could add 3 to both sides. I could say 4 times the cosine squared of x is a positive 3. And if I divide both sides by 4, I get cosine squared of x equals 3/4. Now I don't really want to use my unit circle to find where cosine squared equals a value. I want to know where the cosine equals a value. So if I were to take the square root of both sides, I would say then that the cosine of x would be the square root. I think in algebra class you guys even wrote that step in up here. The square root of 3/4 would be the square root of 3 divided by 2. And the thing you got to remember is that when you solve an equation, remember that you guys solved equations like this in algebra class. If you had x squared equals 16, you knew that both 4 and -4 could solve that. So I need to make sure that that's indicated here too. I took a square root to solve an equation, so I better make sure that both positive and negative options are here. So I need to know where the cosine of x is either positive square root of 3/2 or negative square root of 3/2. So if I pull up my unit circle, we're looking again for the cosine to be square root of 3/2. So I think here is a place where the cosine is square root of 3/2. I think here is a place where the cosine is square root of 3/2. But remember, we needed the negative options as well. So I think I also better list 5 pi over 6 and 7 pi over 6 as well. So I actually have 4 options to give for my answer here. So the solution set here is, and I'll just list all of them, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And all 4 of those values for x solve this equation. You're probably ready now to try the first few in the homework set for this learning target on your own. So see what you can do and try the first couple, and then if you struggle, of course, let me know, and I'm happy to jump in and try and help you out individually. And when you feel like you're ready to move on to the next video, please go ahead and do.